We walk around in 3 dimensions, we see depth, we live in a world that's undeniably 3D. But what if I told you that all the information in our universe, every star, every planet, every one of us, could be encoded on a distant, flat surface, and that this information is somehow projected to create the 3D reality we experience every day? It sounds like something out of a futuristic movie, but the idea has its roots in some of the biggest mysteries in physics, particularly around black holes. Let's go back to 1974 when Stephen Hawking made his groundbreaking discovery that black holes emit radiation. This radiation, now known as Hawking radiation, suggested that black holes might eventually evaporate completely, which led to a paradox. What happens to all the information about the matter that falls into a black hole if the black hole eventually disappears? You see, in physics, there's a fundamental principle that information about a physical system can't just vanish. Even if you burn a book, the information in it isn't lost. It's just scrambled into ash and smoke. So, if a black hole evaporates and vanishes, what happens to all the information about the objects that were sucked into it? This is where the holographic principle comes in. In the 1990s, physicists Leonard Susskind and Gerard Hooft proposed that the information that falls into a black hole isn't lost. Instead, it gets encoded on the 2D surface of the black hole's event horizon, the boundary beyond which nothing can escape. Think of it like a hologram, a 2D image that contains all the information needed to create what appears to be a 3D object. But here's where it gets even more interesting. Susskind and Hooft realized that if this principle could solve the black hole information paradox, maybe it could apply to the entire universe. Maybe everything in our universe, which we experience as 3D, is actually encoded on a distant cosmic horizon in just 2 dimensions. So how did this idea expand beyond black holes to encompass the whole universe? That leap was made by physicist Juan Maldacena in 1998. He showed that a hypothetical universe could be a hologram. He wasn't talking about our universe specifically, but rather a universe with a very different geometry, something called anti-de Sitter space. This space is curved, unlike our flat universe, but Maldacena's work was groundbreaking because it suggested that complex ideas in quantum physics and the theory of gravity could be unified by viewing the universe in 2 dimensions. This unification is huge because for decades physicists have struggled to reconcile the laws of quantum mechanics, which govern the very small, with general relativity, which governs the very large. These 2 theories don't always agree with each other, but in Maldacena's hypothetical holographic universe, they do. And that's why this idea isn't just a fringe theory. It's become an important tool for physicists trying to solve some of the most fundamental problems in the universe. But let's pause here. Does this mean our universe, the one we're living in, is definitely a hologram? Not exactly. The math and the theory work beautifully in these hypothetical scenarios, but proving that our actual universe is a hologram is another story. There's been recent work that suggests the holographic principle could apply to our universe as well. Some physicists have explored how this principle might help explain quantum entanglement, the strange phenomenon where particles that are light years apart can instantaneously affect each other. By viewing the universe as a hologram, they've found ways to make the predictions of quantum physics and general relativity align more closely. But these results are still theoretical and don't provide direct evidence. So how could we actually prove that our universe is a hologram? The most convincing proof would come from making a prediction based on the holographic principle and then finding evidence to support it. For example, the Big Bang Theory predicted the existence of cosmic microwave background radiation, a remnant of the universe's violent birth, and when that radiation was discovered in the 1960s, it was a huge validation of the theory. Some physicists believe the holographic principle might predict a fundamental limit to how much information our universe can contain. Imagine the universe like a high-definition video. If there's a limit to the resolution, then when you zoom in close enough, the picture should become pixelated or blurry. Fermilab's Craig Hogan and his team are actually looking for this kind of blurriness in space-time using a device called a holometer. If they find it, it could be a sign that our universe really is a hologram. But not everyone is convinced. Even Susskind, one of the fathers of the holographic principle, has criticized this approach. The debate is ongoing, and we're still far from any definitive proof. So, what does all this mean for us? If our universe asterisk is asterisk a hologram, how does that change our lives? In a practical sense, probably not much. The laws of physics, as we experience them, wouldn't change. Your day-to-day life would carry on just as it always has. But in a deeper sense, this discovery would revolutionize our understanding of reality. It would be like discovering that the Earth isn't the center of the universe, or that time and space are relative. Proving the holographic principle would be a step towards fully understanding the laws of physics that dictate everything in our universe. It would open up new avenues of thought, and perhaps even change the way we view our place in the cosmos. So while it might not change what you do tomorrow, it could change everything about how we understand the universe in the long run. And that's something truly profound. Don't forget to hit that like button, smash subscribe for more jaw-dropping space updates, and join us as we embark on a cosmic journey like never before.